Alright guys, today we are going to knock out rhombi and squares. So we should be on page 12 of our chapter 6 note packet. Rhombis have the same properties of parallelograms, just like rectangles did, but 3 more that make them unique for just them. So go ahead and pause the video and write down these 3 new characteristics for rhombi. Alright, in problem 1 it tells us that JK is 12 and JN is 7. Well, the first property says there's 4 congruent sides, which tells me that all of these outside sides are the same length. They're all going to be 12, so we can go ahead and fill those in accordingly. And they only ask for one of them. The other ones they say is that diagonals still bisect each other. So if I look, N is still my midpoint, which means if JN is 7, NL is 7. So that makes JL, the whole thing, 7 plus 7, which is 14. But like rectangles, in rectangles it said diagonals were congruent. That's no longer said here. It just says diagonals bisect each other. And then there's 2 new things for diagonals. So congruent diagonals are only for rectangles. For rhombi, we have some new properties for diagonals. One it says is that they're perpendicular. What that tells me is that they're intersecting at a 90-degree angle. So just like we saw in a rectangle, we have a right triangle forming. And whenever we have a right triangle form, we can use our Pythagorean theorem in order to solve for the length of that side. So, across from my right angle is always my hypotenuse. I'm going to make 7a, and the side I don't know, b. So I have 7 squared plus b squared equals c squared. That's going to lead me to 49 plus b squared equals 144. Minus your 49. Get you b squared equals 95. Square root of that. B equals 9.7, which I assigned to NK. But remember, MN will also be the same as that. 9.7. To find MK, which is the whole thing, I would want to do 9.7 plus 9.7, which is 19.4. Now, in a rhombi, that's not the only way that our right angle can appear. So we just need to be careful about that. We might have to solve for side C or side B instead of side A, but we're able to handle that on our own. But your right angles in a rhombus are going to be in the center. In a rectangle, they're in the corner. In a rhombus, they're going to be in the center. Still going to have to use Pythagorean theorem in order to solve for your missing side lengths. On number 4, we're asked to deal with angles. And as far as angles are concerned, we see that opposite angles are congruent. That comes from parallelograms. We see that consecutive angles are supplementary. Again, that comes from parallelograms. And then we have a new one. It says our diagonals bisect opposite angles. What that means is our diagonals are cutting our angles in half. So 38 is getting cut in half on these guys, and I can do the same on the other ones. This would be my diagonals bisecting my opposite angles. So if 3 and 38 are congruent, I can put that there. And opposite angles are congruent, which means 3 and 5, 38 and 4, all of those are going to be equal. So I can float in my 38s. In order to figure out the other ones, in a parallelogram, we learned that if you make up the same side of the shape, you're going to equal 180. So I could do 180 minus my 2 38s in order to find all of this angle, which gets you 104, which is all of this angle. So if it's getting bisected, I'm going to want to divide that by 2. And that's going to get me 52 for angle 1. And 52 is going to be equal to angle 2 because they're getting bisected, so they're the same. It'll be equal to 6 because opposite angles are congruent, and 7 as well because opposite angles are congruent. To find 8, 8 is in the center. And what do we know about our diagonals? We know that they are bisecting each other, but also perpendicular to each other. So that means right here, we got a right angle at that intersection of our diagonals. So 8 would be 90 degrees. If you forget that, we could have gone into a triangle and subtracted away from 180 and gotten the same answer there. All right, go ahead and pause the video and try number 5 on your own. All right, you should have finished number 5, and we're going to turn to page 13, page 13, and we're going to look at squares. So a square has all the properties of a parallelogram, rectangle, and rhombus. So every single property we've talked about is going to flood into a square. For all the other ones, they have distinctive ones that belong just to them. So this box right here is your parallelograms. Any quality listed there belongs to a parallelogram. These two right here belong to a rectangle. If they belong to a rectangle, they also belong to a they also get to have the parallelogram qualities. And then these two, or three right here, belong to a rhombus. And again, they also get to inherit the parallelogram qualities. So there's 3 different boxes, but if you're a green box, you get to have the yellow. If you're a blue box, you get to have the yellow. So in a square, we get to use all of the properties we've talked about. And it tells us that AD is 11. Well, in a square, all 4 sides are going to be equal. It gets that quality from a rhombus. So I know that this is 11. Well, in a square, the corners are going to be 90 degrees. It gets that quality from a rectangle. That sets us up for, guys, our favorite triangle, a right triangle. I can use that right triangle to solve for my missing diagonal. This time, we don't have the hypotenuse because across from the right angle is empty. So I'm going to make this A and this B. A squared 11 squared plus B squared 11 squared equals C squared. Don't know it. 11 squared is 121 plus 11 squared is 121. So that gets us to 42. Square root that. And that gets us 15.6 for the whole length of that diagonal. Oops, didn't write my 0.6. So, if I go through here, I know that BC is 11 because all 4 sides are equal. I just found AC, it's 15.6. It asked for BD. Well, from a rectangle, squares get the quality that diagonals are congruent. So if AC is 15.6, so is BD. And then from a rhombus, from a parallelogram, they are told that E is the midpoint and that all of these are going to end up being congruent because it bisects it, and since the diagonals are congruent, it's going to make all of them congruent. So to find EC, I'd want to cut my whole thing in half, so 15.6 divided by 2 for 7.8. Go ahead and pause the video and try number 7 on your own. All right, let's look at number 9. It tells me it's a rhombus. So we're kind of going backtracked for a little bit. A rhombus, what I know about my diagonals is that it bisects my angles. So what that means is that both of these are going to end up being congruent to each other. So I can set them equal because my diagonals bisect them. And I get 7 for my x value. The angle I'm looking for is angle F to E to D. So I'm looking for an angle that I have no expression with. Well, from a parallelogram, I know that if I make up the same side of my shape, I'm going to equal 180. So that's telling me all of angle F and all of angle E is 180. So I should find angle F and then use that to find angle E. Well, if I plug 7 in to this 5x plus 1, that's going to get me 36. Since they're bisected, I know that they're both equal, so they're both 36 degrees. And again, that whole angle added together would get me 78 degrees. And in order to find the missing one, I can use the fact that they're on the same side of the shape. So I could do 180 minus 78 for a grand total of 108 degrees. All right, let's look at, I have to go through all these. Oh, number 11. I'm told that it is a square. And what I know about squares and my angles is that every corner is 90 degrees. That's from a rectangle. I also know that my diagonals bisect opposite angles. That's from a rhombus. So if I'm looking at that, I have part of a 90-degree angle. It's being bisected, and I have part of it. Well, 90 degrees cut in half is 45 degrees. So I know that the part they give me is going to equal 45 degrees. If you forget that fact, you can always use the fact that since it's bisected, both sides have to be the same, and then do 7x plus 3 plus 7x plus 3 equals 90. Either way, you're going to get 6 for your x value. All right, that's all for today. Again, I know this was a lot of content, and I went really fast through it, but bring any questions you have over rhombi and squares to our next class meeting.